What is going on YouTube? Just helping you out here. And in this video I'm going to be doing Chapter 22, Problem 17 in the Fundamentals of Physics 8th edition textbook by Walker, Halliday, and Resnick. Chapter 22 is all about electric fields, and in Problem 17 we have two charged beads that are on a plastic ring, and we are asked to find the angle of one of those beads, and then we are asked to find the charge of each of the two beads. And so for part A, we need to find the angle of the second bead, and the first thing that I want to do is draw a little diagram. So here's our ring. This is the y-axis, this is the x-axis. And now if you take a look at graph B, we can see that at theta equals 90 degrees, our net electric field in the x direction is equal to 0. So right here, I'm going to draw bead 1, and I'm going to say at theta is equal to 90 degrees, E of x is equal to 0. And so at 90 degrees here, we can see that the net electric field due to bead 1 is strictly in the y direction, which means that the net electric field due to bead 2 must also be only in the y direction, so that there is overall no net electric field in the x direction. And if that is the case, that must mean that bead 2 is also on the y-axis, and so it'll be right here. That's bead 2, and that means that our angle for bead 2 is equal to negative 90 degrees. And before I move on to parts B and C, I want to do one more analysis, and that is going to be figuring out the sign of the charge on the two beads. And so now if you take a look at graph C, we can see that we have a negative net electric field in the y direction with this configuration. And that must mean that bead 1 has a positive charge and bead 2 has a negative charge. And that is because electric fields point from positive to negative. So in this case, the electric field in the y direction due to bead 1 is pointing away from bead 1 and towards the origin, and the electric field in the y direction due to bead 2 is pointing away from the origin and towards bead 2. So in that case, the electric field in the y direction due to both beads is pointing in the negative y direction, which is why we have that minimum in graph C. And that is the rationale behind why we can assign a positive charge to bead 1 and a negative charge to bead 2. And now I'm going to move on to part B. Part B asks us to find the charge on bead 1, and so what we know is that the electric field is equal to charge divided by 4 pi epsilon naught times r squared, where E is the electric field, Q is the charge, pi is the universal constant, epsilon naught is the vacuum permittivity constant, and r in this case is the distance between the origin and our bead, and since our beads are on a circle, this r is the radius of the circle. And we're solving for charge, so what we can do is we can multiply both sides by this denominator, and that is going to give us that the charge is equal to the electric field times 4 pi epsilon naught r squared. And I just said that this is the radius of the circle, so we have everything on this side of the equation except for the electric field. And so we need some way to find that. And now if we take a look at graph B, we see that at 180 degrees, we have a maximum net electric field in the x direction. And so again, if I draw a diagram, bead 2 is fixed, so that's still going to be here, and now bead 1 is going to be over here. So now if we take a look at this, we see that the net electric field due to bead 2 is completely in the y direction, and the net electric field due to bead 1 is completely in the x direction. So we can do a balance in the x direction, and that will allow us to find the charge on bead 1. So what we can say is that charge 1 is equal to E of x times 4 pi epsilon naught r squared. And with this configuration, we know that this E of x is equal to EXS by looking at graph B, and we are given EXS in the problem. So then we have everything we need to solve this problem. So I'm going to plug all of that in. We're going to have that Q1 is equal to 5 times 10 to the 4th newtons per coulomb times 4 times pi times 8.85 times 10 to the negative 12 coulomb squared per newton times meter squared. And now times our radius, which we are told is 60 centimeters. The only issue with that is we have meters squared down here, so we need to convert this to meters, and we know that there are 100 centimeters in 1 meter. Sorry, that got a little cut off there. And now that entire radius term is squared. And if you plug all of that into your calculator, you will find that charge 1 is equal to 2 times 10 to the negative 6th coulombs, which I guess if you write it a little more compact, you can say 2 microcoulombs. Now one thing is we just need to double check our sign. So Q1 is equal to positive 2 microcoulombs. And up here by our analysis, we saw that bead 1 is positive. This is also positive, so that checks out. And that is the final answer for part B. So now we can move on to part C, which asks for the charge on bead 2. And what we can do is a similar analysis to what we did in part B. If we look at graph C, we see that we have a maximum net electric field in the y direction at 0 or 180 degrees. You can choose either. I'm just going to choose 0, and so we can draw a diagram once more. So now we are going to have bead 1 right here, and we will still have bead 2 right here. And again, we have bead 1 contributing to the net electric field strictly in the x direction, and we have bead 2 contributing to the net electric field strictly in the y direction. And so now we can do a balance in the y direction to find charge 2. So what we're going to have is charge 2 is equal to EY times 4 pi epsilon naught times r squared. And on graph C at 0 degrees, we can see that EY is equal to 4/9 of EYS. We are given EYS in the problem, so we can solve for this side of the equation. And I'm going to plug all of that in. We'll have Q2 is equal to 4/9 times negative 9.0 times 10 to the 4th Newton per Coulomb times 4 times pi times 8.85 times 10 to the negative 12th Coulomb squared per Newton times meter squared. And that's going to be times our radius squared, which is again the radius of the circle, and we're told that is 60 centimeters. So 60 centimeters, again, we need to convert that to meters since we have the meters down here, and that's going to be 100 centimeters in 1 meter. That entire quantity squared, just like we had up here. And if you plug all of that into your calculator, you'll find that Q2 is equal to negative 1.6 times 10 to the negative 6 coulombs, or in more compact form, negative 1.6 microcoulombs. And now again, we want to make sure that charge is correct. If we look back at our analysis we did up here, we said bead 2 should have a negative charge, and that's what we see down here. So that is indeed the final answer to part C. And so that's about it for this problem. If you found this video helpful, please drop a like, leave a comment if you have any questions or an idea for a future video, and lastly, please don't forget to subscribe and tell your friends about my channel so I can grow and help more of you guys out. I'm just helping you out. See you in the next video.